Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid. StratusGrid is an AWS Premier Consulting partner, and we're also an independent software vendor. We have a software as a service product that is designed around FinOps, cost optimization, and SecOps security optimization in the cloud, and that product is called Stratosphere. If you're interested in learning more about Stratosphere, head over to stratusgrid.com and feel free to reach out to us, and we can provide a product demo and kind of show you how that can help improve the security and cost posture of your cloud environments. Now, the topic that I wanted to talk about in today's video is a relatively new feature that was released in November of 2023. So, as of August 2024, when I'm recording this video, it's still not even a year old yet. And that is known as S3 One Zone Express Storage. So back on November 28th, 2023, AWS announced S3 Express One Zone Storage class, and along with this new feature that they announced for S3, there's actually a new type of bucket that is available. So as you'll see in the second paragraph right down here, it says that there's a new bucket type called S3 Directory Buckets, in addition to the standard buckets that we've been using for about 18 years now. I think between 2006 and 2024, we've got about 18 years that S3 has been available, just about. So S3 was already pretty high performance using the standard tier, but the S3 directory bucket improves performance. In fact, they are claiming that it can improve data access speeds by up to 10x, which is a pretty significant claim. Also, they are targeting this new feature at any kind of services that need low latency or single digit millisecond access to Amazon S3 object storage. So if you have any particular workloads that are very storage sensitive and need really fast access to data, then you might want to evaluate and test out the performance of S3 Express One Zone storage instead of creating a standard Amazon S3 bucket. Now, keep in mind that this is only available in certain regions. So there's only a handful of regions that are currently available, and I'm sure that they'll be adding more in the future as they typically do. But this is available in US East 1, North Virginia, Oregon, Stockholm, as well as the Tokyo AWS regions. Something that's interesting about the one zone storage here, as the name implies, is that unlike traditional standard S3 buckets, which are regional resources, the S3 Express one zone storage only exists in one specific availability zone that you specify. So when you create one of these new directory buckets, you actually have to specify exactly which availability zone that resource is going to be created in. And you also can kind of think about when you start deploying compute resources like Fargate containers into a VPC or EC2 instances that are running applications, you can actually place those compute resources in specific subnets in a VPC, and those subnets are going to correlate to a specific availability zone. And so you can keep that availability zone where your compute resides close to the storage that is provided by the S3 Express One Zone service. So when you're architecting applications in AWS, you'll want to kind of add this additional criteria to say, hey, previously I only cared about things at the regional level, but for this really performance sensitive application, I need to look at things a little bit more granularly and actually look at the specific availability zones where these resources are being deployed into. So in any case, we're going to be taking a look at how to go ahead and interact with S3 Express One Zone. It is slightly different than Amazon S3 as far as creating a bucket goes, but the vast majority of APIs are similar. They did add at least one new API to list buckets that are using the directory bucket type. So that's a little bit different than the list buckets API for S3 standard storage. So you will notice that if you take a look at the documentation for the S3 APIs. Now, this is the marketing landing page for S3 Express One Zone. There are some pricing changes in S3 One Zone storage here. So you want to make sure you go out to the pricing details for S3 and make sure that you understand exactly what the differences are in costs for S3 One Zone storage, as well as the request costs as well, because you do pay for requests in addition to the actual storage for S3. And depending on what tier of S3 you're using, you can also sometimes pay retrieval costs as well in order to pull data out of services like Glacier. So I'll leave the kind of pricing estimation to you to kind of estimate using the AWS calculator, or you can just kind of do your own math. But what we're going to focus on here is kind of how to interact with directory buckets. And again, most of it's similar. I just want to point out a couple of small differences to you. If you take a look at the documentation for the Amazon S3 service, we're specifically taking a look at the user guide right here. There's a whole separate dedicated documentation section for S3 Express One Zone Storage. And underneath this heading here, there is a section called Directory Buckets here that specifically talks about the differences between general purpose or standard S3 buckets and the directory buckets that are used by Express One Zone Storage. So this just kind of talks about the purpose behind it, the fact that they're limited to specific availability zones, the naming convention where you have the bucket's name followed by a couple of dashes, followed by the availability zone ID, followed by a couple of more dashes, and then the X-S3 standardized prefix here. So they do have a little bit of a bizarre naming convention that doesn't look familiar if you are just using traditional standard S3 buckets. So keep that in mind as well. But again, as far as the APIs go, most of the APIs are going to be the same here. Now, we are going to be taking a look specifically at how to use the AWS SDK for Rust to create a bucket. And so there's going to be just a very minimal change here. So if we take a look at the API reference for S3 here, so if we go one step up and go to the S3 API reference here, and then we take a look at the different APIs that are available, go to actions right here, take a look at the S3 actions. There is the create bucket operation. And we actually use the exact same create bucket operation to create standard and directory buckets. But there's some changes in the actual API itself so that you can create different types of buckets. And so if you search for the word directory in this documentation for the Create Bucket API, it'll call out a lot of the differences. And things like this right here, where it talks about the endpoint that you have to communicate with, you actually don't have to worry about that because the Rust SDK for AWS actually abstracts that for you. So you don't have to manually set the endpoint or anything like that. So thankfully, that makes things really easy. Everything's abstracted by the SDK. You as a developer can just kind of plug into the SDK and utilize it. Now, what I will point out is that when you are creating a bucket, this is what the typical XML data structure looks like. This is the message structure that you're actually passing into the API. And you might be familiar with creating standard buckets where you sometimes have to specify this thing called a location constraint. So even though you're sending a request to a particular AWS region with your SDK, you still have to specify in the S3 API. Most other APIs don't have this, but in the S3 API, you do have to specify the location constraint for where a standard bucket is going to be created. But when you create a directory bucket, that location constraint actually gets ignored entirely. We do have a couple of other parameters here as well. So we have the location parameter, and we need to specify a location, which is going to be the availability zone ID where the bucket is going to be created. And then we also have to specify the type of location, which in this case is an availability zone because it's no longer a regional resource. This is an availability zone specific resource instead with the Express One Zone storage tier. Now, under the bucket details right here, we have data redundancy. So this is single zone redundancy that we have here. And then the type of bucket is going to be of type directory rather than a standard bucket. So these are some of the parameters that we need to pay attention to when we are creating a specific directory bucket. Now, you also want to be aware that there are limited support for not just regions, but availability zones as well. So you'll probably want to take a look at the AWS Management Console to see exactly which availability zone IDs you can use in a particular region to create a bucket using the Express One Zone storage tier. So those are a couple of differences that we have here. If we take a look at, let's search for the word constraint here. If you look for the location constraint input to the payload for creating a bucket, you're going to see this note right here that says this functionality is not supported for directory buckets. We only have to specify that additional location constraint parameter if we're creating standard buckets. Same thing for the bucket details. We have this bucket info data type right down here where we pass in the value of single availability zone, and then the type is going to be directory. when we create a directory bucket. And then for the location details here, we have this location info data structure. And so for this, we have the name of the location. So that could be, for example, USW2, that would be the Oregon region, US West 2, and then AZ1. And then there's actually a couple other availability zones, AZ number 3 and 4, that are also supported, but there is no availability zone 2 that is supported in this particular region. So you want to again look at the console just to make sure that you're understanding which AZs are supported for this feature here. And then the other thing that you're going to have to specify under the location info data structure here is the type of location. And again, because we are creating a directory bucket instead of a standard bucket, this is going to belong to a specific availability zone. So the only valid input value there is just availability zone because we're tying that directory bucket to a specific AZ. All right, so we are going to go ahead and write some simple code just to kind of show you how using the Rust SDK for AWS, we can create one of these directory buckets and some of the caveats you can potentially run into if you specify an invalid bucket name, an invalid availability zone ID, if you specify the location constraint and you're not supposed to, you get these kind of vague error messages saying that your XML is malformed. And most APIs are JSON based, but the S3 API is one of the original, if not the original one that was released as part of the AWS platform nearly 20 years ago at this point. And so it does actually use these XML payloads that you can see right up here. All right, so let's go ahead and take a look at the code. Also, I will point you to an article right here over on the GitHub project page for the AWS SDK for Rust, which is under the AWS Labs GitHub organization. There is a discussion titled Using S3 Express One Zone from the Rust SDK. And so right down here, it kind of shows you the example, how to create the bucket configuration, how to just specify a string for the name, and you have that suffix on there with the AZ ID, and then the standard dash dash x dash S3 suffix on it, and then the basic create bucket uh, API call that we have right here. Now, the nice thing about the APIs is that when it comes to actually reading and writing data to and from an S3 directory bucket, you actually don't really have to make any changes. So the put object API and the get object APIs are basically just the same here, right? You pass in a message body, a key for a name for the file that you're trying to upload, and a bucket name as well. So the APIs for that read and write operation is pretty similar. The one other thing I'll point out that's a little bit different, and I think I briefly touched on this verbally, is that there is an API called list directory buckets, and that will tell you the directory buckets that are in a particular region. So down here, we've got the traditional list buckets API, and then we also have list directory buckets, and this is specifically for the directory buckets feature. In addition to these API changes, I did also want to point out that there are some additional permissions that are available in the Identity and Access Management service. So when you're creating an IAM user or a role or some identity that's going to access these S3 Express One Zone APIs, you have to make sure that you explicitly have access to the create bucket and list bucket operations for the One Zone storage tier, the Express One Zone storage tier. And so those are under the S3 Express prefix rather than the S3 prefix, which you are typically accustomed to when you are setting permissions. And so what that means is if you are using the built-in AWS managed policy called S3 full access, I want to say is the name, then that actually doesn't include the additional permissions that you need to access the S3 Express APIs. And so you have to create your own policy in order to grant access to these S3 Express One Zone APIs. So just keep that in mind as well. All right, so what we're going to do now is go ahead and spin up a Rust project. And I'm also going to go ahead and show you how to set up the IAM user and credentials and the specific permissions for this particular project here. So in the AWS Management Console, we're going to head over to the IAM service here. We're just going to create a new IAM user. Let's do create user, and we'll call this Trevor-SG-S3 one zone. We'll hit next here. Then we can specify the policies. And of course, you might say, all right, I'm going to do Amazon S3 full access right here. If you take a look at the permissions though, you'll see that the filtered permissions are only S3 star and S3 object lambda star. There is no S3 express prefix in this policy. So I am going to go ahead and add this policy just in case so that I have access to all these other S3 APIs if necessary. But then I'm going to hit next. Let me just add an owner tag here so my teammates know I own this resource. We'll go ahead and create that user, go to the user details, and then we're going to create a new inline policy. And I'm going to search for S3. But when we search for S3 here, see how we have S3 Express. We're going to choose S3 Express. And then if you take a look at all the individual permissions down here, we have S3 Express create bucket, create session, and then we also have this list all my directory buckets permission as well. And list all my directory buckets permission in IAM is actually what maps over to the permission that we use right here. So see in the documentation for list directory buckets, it says list all my directory buckets is the actual name of the IAM permission. So the name of the permission is just slightly different than the actual REST API itself, but those correspond to each other. So over here in our user permissions in this inline policy, we're just going to choose all those, and then I'll just say it works for all resources for the time being. You can also choose this box up here just to enable everything for that S3 Express API. We'll hit next, and we'll just give it a name like S3 Express all, and then we'll hit create policy. All right, so with that policy created, we're going to go generate some security credentials right here. So we'll create an access key, go to other, next, and I'll just call this S3 Express dash delete me. The name of the access key doesn't really matter too much, honestly. And then we'll copy the access key and the secret access key as we typically do anytime we're dealing with the AWS SDKs to our clipboard. And now we are just about ready to go ahead and spin up a Rust project. So let's head over here to our Git project directory, and I'll use the cargo CLI to say cargo new SG S3 dir bucket. And then I'll go ahead and open up Microsoft Visual Studio Code, and we'll open up that particular bucket in VS Code. Now, for some reason, you don't have the cargo CLI available. That's part of the Rust toolchain. And so if you're following along and you need to install the Rust toolchain, like the Rust C binary, for example, or the cargo CLI, all those different tools or those binaries are part of the Rust toolchain, which you can get at rustup.rs. So this is an installer that allows you to install the rustup toolchain installer. And so you can just run that on your system. That should work on Mac OS, Linux, or Windows for that matter. And then once you have the rustup installer, you can just do a rustup and then say install, I think, or rustup toolchain. And then you can say, list the current tool chain. So I have the stable tool chain installed, but you can also install additional tool chains as well. So if you want to install the nightly, the beta, it's kind of up to you what tool chain version, but typically the stable one is going to be the one you're most likely going to want to use. Okay, so with that out of the way, we are going to come into VS Code here. We bump up the font size a little bit here, and we're going to embed our credentials in a .env file here. You might have seen me do this in other videos. So we'll say AWS access key ID equals, and we'll paste that in, AWS secret access key equals that. And then we'll set our AWS region to US West 2 because that is one of the supported regions for the S3 Express one zone feature. Go ahead and save that file. And now we are going to install some dependencies. So let's say cargo add.env. That's what we're going to use to actually load that .env file with our environment variables. Also, we want to go to our git ignore file and just add .env there so we don't include that by accident in our git commits. Then the other thing we're going to do is say cargo add Tokyo features full, and that's going to install the Tokyo async executor for Rust that is typically used by the AWS SDK. We're going to add the AWS config crate with the behavior version latest feature. That's just a Rust implementation feature there, or implementation detail, I should say. And then we're going to add the AWS SDK for Amazon S3 as well. And I always tend to forget one dependency here or there, so we might have to come back and add some additional things, but I think that that's everything. All right, so we've got AWS config, we've got .env, S3, Tokyo. We should be good to go here. Let's open up our main.rs file. We'll add the Tokyo main attribute here, and that'll allow us to turn our main function into an async function. Then what we need to do is to load our credentials. So we're going to do .env and then call the .env function here, and we'll just discard the result there. We're not going to do any error handling on that for the time being. And then we're going to start by loading our configuration. So we'll do AWS config, and we'll say load from env. So that'll just load from the environment variables. We'll go ahead and await that and assign the result to a variable like AWS CFG. Now, once we've got our credentials loaded here, we can go ahead and create an S3 client. So let's do AWS SDK S3, and we'll create a client with the new function, and then we'll borrow the AWS CFG variable, and we'll assign that to a variable like S3 client. All right, so now I've got this client object, and we can call different APIs using this. Now, I did want to show you in the AWS Management Console here, if I go to the S3 console here, we can actually see a list of directory buckets that I've already created in this region. So if you go to S3 console, make sure you're in the correct region here. I'm in US West 2, Oregon. If you go to buckets here, you can choose the directory buckets tab. And then under here, you can see the individual directory buckets that I've already created. As you can see, they do follow that kind of bizarre naming convention that we have for directory buckets, and it tells you which availability zone each of those buckets has been created in. Now, if I hit the Create Bucket button right here and choose the directory bucket type, you can see I can choose an availability zone. And in this particular region, US West 2 Oregon, I only have AZ1, 3, and 4. There is no AZ2 available for this particular feature. And you also have to acknowledge, if you're creating it through the console, that it is stored in a single availability zone. So an availability zone outage can potentially cause a loss of data. And then in the console, if you create a bucket like Trevor SG, and we choose a zone like AZ4, you can see that it adds on that standard suffix with the double dashes surrounding the AZ, and then the X-S3 on the very end. So we have to make sure that we follow that convention when we are creating directory buckets. But we're not going to be using the AWS Management Console to create buckets. Instead, we're going to be using the Rust SDK here. So after we create our S3 client here, the next thing we want to do is call S3 client dot create bucket. And then typically when we do a create bucket operation, we specify the bucket name, which is the bucket parameter here. So we're going to create a variable here called let bucket name equal whatever our bucket name is going to be. And I'll just do Trevor SG dash YouTube, and then we'll do dash dash USW2 dash AZ4 dash dash X dash S3. That should be the correct suffix here. So I'm going to create it in AZ number 4 in US West 2. And then we can pass in this variable, bucket name, for our input there. And then, as is typical with other AWS APIs that we call, regardless of what service it's on, we always do .send to create a future, and then we await that future to actually execute it. And then we'll capture the create result here. So we'll create a variable called create result and just assign the result of the create bucket operation to that variable. And then if there is an error, so we will say if create result.is error, then we're going to say print line, and we'll do a debug output here, and we'll pass in the create result dot error. Okay, so now if we get an error, it'll print out the error message. It'll print out a whole ton of information, most of which we don't need, but that's just kind of the easiest way to spit out some of that detail. So now what we need to do is make sure that we have all of the input arguments to the creation, the create bucket API here, we need to make sure that all of those inputs are set correctly. So let's go ahead and try cargo run here and see what happens. So the first time we do a cargo run, it's going to build out all of our dependencies here. Then it'll finally compile our program and execute the debug build for it. So that'll show up under our target directory right over here in our project. We got target, debug, and then our binary is just going to be under, I think it's under the build directory here. And so it'll execute that debug build. So let's give that a second to compile. And we're most likely going to get some kind of error from the creation of the bucket because we have not specified the bucket configuration details that we need to. So if we do dot create bucket configuration, this will actually take in a data structure called a create bucket configuration data structure that we need to construct that contains the location details and the other information that we looked at in the create bucket API. So it looks like we got an error here. Looks like more of a syntax error. So we have an error with send await, and that's probably because I was modifying the code while we were building there. So let's just try to recompile it once again with this line number 14 commented out. And as you can see, we do actually get a service error here, and it says missing request body. It says request body is empty. So what we need to do is make sure that we fill out the create bucket configuration that contains some of those additional details. So let's actually construct that as a separate line item here. So we'll say bucket conf equals create bucket configuration builder. So that'll automatically import it. If you have Rust Analyzer for VS Code installed, it'll just automatically import the type when you hit enter, and it'll auto-complete that for you. So what we're going to do is say we're going to call the default here, and that's just going to create a standard create bucket configuration builder. And then after we specify the inputs to it, like the bucket details and the location details, which are child data structures of their own, then we can finally call the .build function there, and that'll turn the builder into the actual create bucket configuration data structure. So we can take this bucket conf and pass it in for the create bucket configuration, and that'll satisfy the input argument to this parameter here, or to this function. All right, so what we need to do is specify the details. We got to do dot bucket and dot location. So if you recall, we have these data structures in the APIs. Let me actually go over to the create bucket API right over here. And so if we take a look at the input payload here, we have the location that has name and type, and then we have the bucket, which has data redundancy and type. So those are the two child data structures that are part of the create bucket configuration object that we have to pass in here. So what we need to do in order to construct those is construct them separately, just like what we're doing with the create bucket configuration builder here. So we'll specify .bucket, and we'll say bucket info as a variable. That'll just be a placeholder. We haven't actually declared it yet. And same thing for location. We'll just say bucket location as a variable. And so those are both placeholders, and we actually have to go declare those. So let's find out what the data type is that we need here. So it's going to be a bucket info object. So let's say let bucket info equal a bucket info builder. And then we'll do the default function on there. And then we can do dot data redundancy. And we can also do dot type down here. And that'll allow us to specify a bucket type. And then we'll do dot build to turn the bucket info builder into an actual bucket info object. So for the data redundancy here, this is going to take in a data redundancy type here. I'm guessing that's an enumeration. If we check out the documentation for the crate, we can find out exactly. So if we head out to crates.io, take a look at the S3 SDK here. Let's look for the AWS S3 SDK. Let's just do a search for the full name there. And then we'll open up the documentation right here. And if we go to child modules, so that is under crate types and then data redundancy. So let's go to the types submodule here, and then it's called data redundancy, I think. Is that what it's called? Data redundancy, crate types, data redundancy. I'm not seeing that in the list there. Let's go down to enumerations. I think that's probably what it is. Yeah, so there it is, data redundancy. And there's only two different variants for this enumeration. There's single availability zone and unknown. But of course, since we're using express one zone storage, we need to choose single availability zone right here. So what we'll do is just say data redundancy, and you can see that the Rust Analyzer extension will auto-complete that value for us. So we'll just hit enter there. Also, you could put in a use statement if you want to shorten that just to, data redundancy, single availability zone. But I'm just going to resolve it using the fully qualified path there. And then for the type here, the reason we have our pound sign in front of that is because this is a reserved keyword in the Rust language. And so we can't have a type function there. We actually have to do that because that's a reserved keyword. You can look at all the reserved keywords in the Rust documentation somewhere, but I'm pretty sure that's why that's happening. And then for this, we have a bucket type. And so if we take a look at the types, crate types, bucket type, I'm guessing that's under enumerations as well. Take a look at bucket type. Sure enough, we have two variants, directory or unknown. So of course, we're going to say bucket type, directory bucket, and that'll satisfy the bucket info. So when we call build, that takes the builder and it turns it into a bucket info. And then we take this bucket info variable and we pass it in to the bucket parameter here for the create bucket configuration. Same thing for the location details, where we're going to do let bucket location equal the, what data type do we have here? This is going to be a location info data type. So we'll do location info and we'll say, give me a builder. Actually say location info builder default dot build. And then the two inputs to that are going to be the name and the type. So let's do dot name dot type. And so the location type here is going to be the data type for the type. So we'll say location type, availability zone. And then for the name right here, we need to specify an availability zone identifier like USW2-AZ4, which is the AZ that we're going to be creating our bucket inside of, as you could see from the name that we assigned to our bucket right up here. So we can basically just take this identifier right here and pass it in. Let's put some quotes around that as well. And so now we've satisfied all of those inputs. So now we are going to call S3 client create bucket, specify the bucket details. That's going to be the create bucket configuration builder, or that's actually the bucket name. And then we have create bucket configuration. That's our create bucket configuration builder that turns into a create bucket configuration data structure. And so let's go ahead and give this a try and see if this works. We'll do a cargo run and hopefully we won't get any errors. If we do get some errors, it could potentially be because we specified an invalid availability zone. It could be because we specified a location constraint and that's not supported for directory buckets. It could also be because we specified an invalid name for the bucket. But it looks like this did actually work. So let's head back over to the AWS console right over here. We'll go back to buckets in the Oregon region here. And if we refresh, you should see that we have a third bucket here. So it's this one right here. It was created in US West 2 AZ number 4. And of course, there's no objects in it because we haven't uploaded anything into it just yet. Okay, so that's how we can create a bucket. If I was to try to change the name of the bucket, like put a number 2 after it, and then just eliminate the rest of the suffix there, what do you think is going to happen? Well, we're probably going to get a malformed XML error. So it says, yeah, malformed XML. The XML you provided was not well formed or did not validate against our schema. So that's a good indication that, your bucket name is wrong. So if we put that suffix back on there and we rerun our program here, it should work perfectly fine. And sure enough, we didn't get an error printed out. So we should have 4 buckets now. All right, there we go. So that's how you can create directory buckets. But remember, as far as listing directory buckets, we don't have a list buckets API like we do for standard buckets. We have a separate API called list directory buckets that lists the directory buckets in a particular region. So what we'll do to list the buckets is basically just comment out all this code here. Let's just comment this out for now. And then after creating the S3 client, we'll just say S3 client dot, and then we'll search for directory because there's only one that matches the name directory, list directory buckets. And then we'll say dot send dot await, and that's going to operate against the region from our .env file that we created in the root of our project directory, which is US West 2 right here. So the region is coming from there. And we'll capture the result as dir bucket list. And then we will, because we have this result object right here, we'll just say dot expect and then give it a custom error like failed to list directory buckets. And then down here, after we get our output here, this list directory buckets output data structure, this will kind of wrap all the different buckets. So it actually has a child field called buckets that allows us to get a vec of buckets. So if we say for bucket in dir bucket list, do dir bucket list dot, my auto completion is failing here, dir bucket list dot, and as you can see right here, we've got dot buckets. That is an option type that is wrapping our vec of buckets. So we need to do dot unwrap. So dot buckets dot unwrap to get the underlying vec from the option. And then what we can do is say for each bucket, we'll go ahead and just print out the name of the bucket. We'll say bucket name is, and then we'll say bucket dot name. And the name field of the bucket itself is also a string that's wrapped in an option. So we need to do dot unwrap on that as well. Okay, so let's just try this out and see if it works. We'll say cargo run, and hopefully we'll get a 4 lines of printed statements saying these are your S3 buckets. Awesome. So that seems to be working just fine there. And if we take a look at the bucket type, I just want to make sure that there's not some availability zone field on there that we could potentially use. So let me figure out where that bucket type is coming from. So right here we have the bucket. It's an AWS. Let's see. Trying to hover over it here and see what data type that is. It's AWS SDK S3 types and then underscore bucket. Obstruct bucket. And it only has name and creation date on it. So in order to figure out which availability zone it belongs to, you'd probably have to just extract that from the bucket name because the availability zone is part of the bucket name. It's not a separate field on the actual bucket itself. So that's one thing you'll probably want to pay attention to is just if you need to know which AZ a particular bucket belongs to, you can just parse that out by kind of splitting on these double dashes here or something like that. Okay, so that's how we can list buckets. Also, if I was to change the region, so let's say I go over to the US East 1 Northern Virginia region here, and then take a look at directory buckets over here. You can see I do have one bucket over here, and that bucket wasn't listed because I was only operating against the US West 2 region. So if we were to change our env file here to say, hey, I want to target US East 1 instead, if we just rerun our program here, you can see that we just get that one bucket printed out. So wherever your AWS configuration object that you load from here, or there's some other ways that you can creatively override the region in the configuration, it's kind of beyond the scope of this particular video, but whatever region it is that you're pointing your AWS configuration to and then constructing the client from that configuration, that's the region where the directory buckets in whatever availability zone they belong to are going to be retrieved from using the list directory buckets API right here. Now you might be wondering, well, how about writing data? Well, writing data is just the exact same as standard buckets. So if we do S3 client dot put object, Then we'll specify our bucket name, so dot bucket. And before I forget, I'm going to change this back to US West 2. And I'm also going to grab my bucket name from down here. I'm going to take that number 2 off the end there. And let's just move this up somewhere right up here before we actually need to use it. So we'll say let put result equal whatever the result of this operation is. We'll do .send.await as with any API call. The bucket name, we're just going to pass in from the variable bucket name. Then the key, I'll just hard code something here like test.txt, and then we'll do dot body. And the body is something called a byte stream object. And so if you just start typing byte stream, if you have the Rust Analyzer extension installed, you can actually do from static here, and then you can pass in a byte slice. And so what we could do is just specify some static text like hello from Rust, and then say dot bytes and or dot as bytes actually, and that'll give us a byte slice. And so then we can construct a byte stream kind of inline using an inline string that we have here. So that works perfectly fine. And then we'll just say if put result dot is error, then we'll go ahead and print line and grab the debug output and pass in put result dot error. So if we do get an error, it'll print it out. Otherwise, it just will not print out anything. And if we do a cargo run, we should see it add a new object into there. So we didn't get any errors. That's definitely a good sign. If we come back over to our buckets in the Oregon region, I'm going to find the one named YouTube without the number 2 on the end. So this one right here. And sure enough, you can see test.txt is in there with 15 bytes. I could just change it to something else like hello from Rust and Trevor, save that and call it test2.txt, say cargo run. We should get another object created. So sure enough, no errors occur. If we refresh right here, now we've got test2.txt, and it is 26 bytes in size right there. Cool. So I hope this has been helpful for you, that you've kind of figured out a little bit about how the Express One Zone storage tier works. Again, it's kind of designed for higher performance with a little bit more limited durability than what you're accustomed to with S3 standard or standard infrequent and glacier types of storage. But it does give you the option to get higher performance and to place your compute workloads closer to exactly where your object storage is located. If you deploy your compute resources in the same availability zone, a specific subnet that is the same as where your S3 directory bucket resides. So hopefully this has been helpful for you. Leave a comment down below, leave a like on the video, and subscribe to the StratusGrid video channel so that you can get notified about future videos. Until our next video, take care.